Hello, my name is Mathias Mahn. I work for Vishay as a field application engineer, and today I'm going to show you what Vishay products could be used for alternative energy solutions like, for example, PV inverters. We developed in the recent months a reference design which was made by our own department, and there we are using our latest generation MaxSiC silicon carbide MOSFET in the second generation, and to show how it's working for an auxiliary power supply system. An auxiliary power supply system is needed for PV inverters when they need to work out of the grid in an island solution, and therefore the PV inverter needs to work without voltage from external, and so the PV inverter needs to be powered from the power which is coming from the PV modules, and therefore it needs a really high input voltage range, which is defined by the number of PV modules connected to one string, and also because of the light conditions which is coming from the sun, the voltage varies a lot at the input of the PV inverter, and therefore we need a very high input voltage range from, for example, in this design for 100 to 700 volt DC input, and this design converts it down to 24 volts output voltage at a maximum power rating of 35 watts. And this main device is the switching device, which is our silicon carbide MOSFET in the second generation, and we also built a custom transformer for the reference design, and also our hyperfast rectifier, which is converting the voltage at the output of the transformer to the 24 volt DC voltage, is also really a focused product of Vishay, which could be used for solar PV inverters. And also at the input you can see our MKP 1848 DC link capacitor, which could be used to make some filtering at the input, and also for this device it's very good because it needs some quite stable input voltage to operate at a high efficiency. Our microbuck converter could be used to convert down the 24 volts into 5 volt, and which is then used to power the microcontroller in the PV inverter and other things like sensors and whatever is needed in the PV inverter. So I'm going to show you some other things. This is one PV inverter which was supplied from some customer to us, and a lot of Vishay components were used in this PV inverter. I'm going to show you more in detail next. We start at the input, where our NTCs are used to limit the input current, and then it goes to DC link capacitors, which are, in this case, our MKP 1848 film capacitor is used, and also this one are also Vishay components. Our aluminum capacitors could be used also as DC link capacitors, and we also supply the silicon carbide diodes, which are on the back of the PV inverter. And also our MEF resistors are widely used in the PV inverter, and also some of our inductors. And then when it comes to the output, again, our MKP 1848 DC link capacitors are used in the PV inverter, which shows that Vishay parts could be used overall in the PV inverter. For more information, please visit vishay.com.